All right, lesson 3.4, solving equations with variables on both sides. All right, here we go. I'm not gonna read through these. You can read through them later if you want. I'm gonna jump in with example number 1. Here we go. Okay, here's what I kind of want to talk to you guys about. So in the past, if we had this problem, if it looked like this, like we'd be super happy, right? Like this is exactly the kind of stuff that we're used to. So what's messing it up is this minus 2x right there. So let's talk about the fact that we can just get rid of this, right? I can get rid of this. If I have a minus 2x, if I add 2x, right, that gives me 0. These cancel each other out. All we got to do is remember that we have to be fair, we have to be balanced. So if I add 2x on the right side, I have to add 2x on the left side. Please pay attention. Make sure you only combine like terms, right? X's with x's or constants with constants. So 7x plus 2x is 9x. Still got that minus 4, and this is equal to 23. Okay, perfect. This looks like the problems we've been practicing. I'm going to go ahead and get rid of this minus 4 by adding 4 to both sides. So now I've got 9x is equal to 27. Finally, divide both sides by 9 to get the x by itself. And I've got x is equal to 3. Okay. Now, we got to make sure we check our answers here. So I started with this equation that had 7x minus 4, and it was supposed to be equal to negative 2 times x minus 3. Here we go. Sorry, plus 23. Sorry. Okay. Now, I think x is 3. So I'm plugging in 3 here for both of these. Now, these are a little different from what we used to check. The way that we check these is we type these in our calculator, just each side by itself. So over here, I'm going to type in 7 times 3, because I think x is 3, minus 4, and I get 17. All right, 17. On the right side, when I type in what I have on the right side, so this negative 2 times 3, and then plus 23, I'm getting also 17. Guys, this means that I am correct. It means that when I use the number 3, it makes the left side equal to the right side. Okay, 3 worked. That's my answer. It made the left side equal 17, the right side equal 17, so they equal each other. Okay? That's how you check problems that aren't just equal to a number. Right? If you have x's on the other side, this is how we check. Let's go ahead on problem 2. In problem 2, before we do anything else, let's please clean this up. I've got a 5x minus 2x on this left side. I should just be saying that's 3x plus 3. Right? I'm not doing stuff to both sides of my equation, I just cleaned up the left side. Now there's nothing left to simplify. Now I have to start actually manipulating both sides of my equation. And again, this is the term I don't like. I'm going to get rid of it. It's a positive 6x, so if I subtract 6x, I get 0. They cancel. Don't forget to keep it balanced. I got to do it on the left side as well. So 3x minus 6x is going to give me a negative 3x. I still have that plus 3. It's also equal to negative 3. Okay, lots of 3's. All right. To get rid of this positive 3 on the left, I'm going to subtract 3 from both sides. So now I've got negative 3x equals negative 3 minus 3 is negative 6. To finish this off, we're just going to divide both sides by negative 3. So I'm left with x is equal to 2. Negative 6 divided by negative 3 is 2. Okay, let's check our answer. Always check your answers, guys. Always. Here we go. So 5 times x plus 3 minus 2 times x is supposed to equal 6 times x minus 3. I think x is 2. So that's what I'm going to put in there. That's what I'm checking. Okay? All right, let's start with this left side. When I plug that on my calculator, if you want to do this in your head, you can. Just make sure you're doing correct order of operations. Got minus 2, parentheses, 2. Here we go. Okay, left side's giving me 9. The right side hopefully also gives me 9. Here we go. 6 parentheses, 2 parentheses, minus 3. And we get also 9. Okay, we checked our work. We're good to go. 2 is our answer. All right, I'm just going to warn you. The last two problems are weird. They're special cases. They're things that don't normally happen. So just be aware that they're strange, okay? Let's start off right how we normally begin. So I've got a 1 and a 3 on this left side. Let's combine like terms. So I really have 5D plus 4. On the right side, I've got a 2D and a 3D to combine. So really I've got 5D and still plus 6. Now hopefully we'll get to a point where just this statement alone raises a red flag in our brain. But let's just keep going. Let's see what happens. This is the term I'll always get rid of next, so let's do that. If I subtract 5D from both sides, something weird's happening. Like everything gets canceled. That's not usual. That's very strange. So what I'm left with is this 4 equals 6. That's not true. Okay, that's not true. Where's my variable? My variable's totally gone. You guys, this is because there is no solution to this problem. There is no solution to this problem. If your variables cancel each other and you don't have any left, it's a weird situation. If you got 1 or 2 choices for your answer, one of those is going to be no solution. Can we focus for a second, though, on this line right here? Like, let's just erase these real quick. If I have 5D plus something else, and I have the same 5D plus a 6, that shouldn't make sense, right? That shouldn't make sense. That shouldn't work. I shouldn't be able to multiply 5 times something and add 4 and have it equal 5 times something when I add 6. Like, there's just no way to make this problem work. And that's why we say no solution, okay? All right, let's look at problem 4, last one. By the way, this is not a common occurrence. I just want you to know that it is possible. Example 4. Yeah, this thing is a mess. Let's clean it up. 4m plus 2m is 6m. We still have that minus 6. On the right side, I got 7m minus m, which is just 1m, so we still have 6m. Negative 8 plus 2 is negative 6. All right, hopefully another red flag is going off, because this time I've got the exact same thing on the left that I do on the right. So think to yourself right now, what can you use for m that will make the left side equal the right side? Well, whatever I plug in here, I'm going to subtract 6. And then I'm going to plug it in again and get the same thing and subtract 6 again. So, like, does the number 1 work? 6 times 1, let's just try it real quick. This will give me 0. And this will give me 0. Okay, I guess the number 1 works. Well, guess what? The number 2 also works. If I plug in a 2 here, and I plug in a 2 on the right, 12 minus 6 is 6. 12 minus 6 is 6. Guys, I'm trying to illustrate a point for you here. Anything works. You know what I mean? Like, they're exactly equal to each other. Anything you use for m is going to work. It's going to make the left side equal to the right side. Now, let's pretend like you didn't even notice. You just kept going. You went ahead and did the steps. You said, okay, well, 6m minus 6m, cross it out. But then you got here and you said, oh, crap. Both my variables canceled like Miss Rogers said could happen. It's a weird situation. Only this time, look, you're left with a true statement instead of a false statement. Guys, this doesn't mean there's no solution. That means that anything works. And the way we say that is we say infinite solutions. Okay, we say infinite solutions. Okay, so if both your variables cancel, you've got a weird situation. It's either no solution or infinite solutions. All right, flips over to the back. We've got 2 more problems to look at really quick. We're trying to find the mistake here. So we're going to look and we're going to see what they did. Okay, looks like they did 3m plus m and got 4m. Okay, that works. On the right side, they did 7m minus 2m and got 5m. Okay, that checks out. Let's look where we are now. Okay, this left side didn't change at all. The right side looks like they did negative 7 plus 1 and they got negative 8. Okay, well that's wrong. What should they have gotten? Well, negative 7 plus 1 should be negative 6. So when it says what step did the error occur, that would be step 2. All right, whatever's labeled on that left side where you found the error, that's your answer. Okay, all right, last but not least, here we go, example 6. Let's see what they did, see if we can spot the mistake. Okay, looks like they combined 5m plus 2m and got 7m. That works. On the right side, though, we've got 9m minus 4m giving us 5m. Okay, that also works. All right, again, left side didn't change yet. And the right side, negative 8 plus 3 gave us negative 5. Yep, that works. Okay, let's look at this next one. Okay, looks like they did a couple steps here in this next one. Check it out. I'm seeing that they must have subtracted 5m and 5m and gotten 2m. Okay, that works. But then look at their regular numbers. They must have added 6 to both sides, and they're getting negative 1. That's wrong. Right, what should this be? This should be, right, negative 5 plus 6 should be positive 1. So the step that was wrong in this case was step 3. Okay? Guys, please make sure that when you do these problems, you check your work. You will never be sorry when you're checking your work. Good luck.